Hello everybody and welcome back to Advanced Maths. Today we're looking at interquartile range and box plots. Let's start with interquartile range. Interquartile range tells us how spread out the data is in the middle. And I've got some data here to show you. And you can see there's some crazy extreme values here. The 1 and the 635 are a long way from where the middle of the data is. The middle of the data is between 23 and 27. So we call these extreme values. And if we were just interested in where the data is in the centre, we would just look at the 23 to 27. And that's what interquartile range helps you do. So the interquartile range finds the quarter positions. That's the first quarter, the halfway, and the 3 quarters. You can see I've split it into quarters here, and you see this is the quarter position, the halfway position, and the 3 quarters position. This is the lower quartile, this is the median, and this is the upper quartile. Okay? Now the interquartile range is given by the upper quartile, subtract the lower quartile. Here the upper quartile is 27, the lower quartile is 23, you subtract them, and the interquartile range is 4. Okay? Let's see that in action. So I've got this set of numbers here. And to save us time, I've got some formulas for the lower quartile, the median position, and the upper quartile position. I've also labelled the numbers, so I've got the position here. So the first position is 2, the 15th position is 23. And it helps us keep track of where our numbers are. There are 15 numbers here. And so to find the lower quartile position, what we do is do 15 plus 1 divided by 4. To find the median position, we do 15 plus 1 divided by 2. And the upper quartile position, we do 3 times 15 plus 1 divided by 4. If you type that into your calculator, you get these numbers here. Like this. 4, 8, and 12. And so what that tells us is that by putting the number of numbers n as 15, we know the first quarter is at the 4th position, the median position is at the 8th position, and the upper quartile position is at the 12th position. So the lower quartile will be 5, the median will be 10, and the upper quartile will be 15, like this. Feel free to rewatch that section of the video again if you need to see it in action one more time. So we know the lower quartile is 5, median is 10, and upper quartile is 15. And the interquartile range is 15 minus 5, which is 10. And so we've got our final answer here. Now let's look at box plots. Box plots help us visualize the minimum, the lower quartile, median, upper quartile, and the maximum numbers in the data set. It looks like this, where the first bar is the minimum number, the second bar is the lower quartile, the median is the third bar, fourth bar is the upper quartile, and then the last bar is the maximum number. And it helps us visualize where all the data is, and it also splits it into quarters. So this first gap is the lower quartile, this gap here is the second quarter, then the third quarter, and then the fourth quarter. It also helps you visualize where all the data is in the middle. So this box in the middle tells you where the 2 quarters in the middle are gathered. Let's see some examples of this. So this data set here, you can see a lot of the data, half of the data is in this gap here, whereas the other half is all spread out. So you might say this data is concentrated towards the start. This box plot here is roughly evenly spread. It's a quarter, 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 quarter. So it's fairly evenly spread out. This data set here, a lot of the data is squashed together in the middle. And so you would say a lot of the numbers are between 13 and 16, where it's gathered here. And so it kind of tells you where the data is concentrated. Let's see an example of this, and we're going to draw a box plot of this data here. 14, 21, 35, 20, 12, 26, 13, 16, 19. And the first thing I have to do is put them in order. So I've rearranged all those numbers in order from smallest to biggest. Now there are 9 numbers here you can count. There are 9 numbers, and so n is equal to 9. I'm going to put 9 into these numbers here, like this. And when you type these formulas into the calculator, you get the lower quartile is in the 2.5th position, the median is in the 5th position, and the upper quartile is in the 7.5 position. So here are those positions marked. The 2.5th position will be between the 2nd position and the 3rd position. The 7.5th position will be between the 7th position and the 8th position. Okay, and that's completely normal. There's no problems with that if that comes up in your exam. The 2.5th position is halfway between 13 and 14. And halfway between 13 and 14 is 13.5. If you can't do that in your head, you do 13 plus 14 and then divide by 2. Similarly, 21 plus 26 divided by 2 is 23.5. And that is it gives you the upper quartile. I'm going to put that data into a table now. The minimum is 12, lower quartile is 13.5, median is 19, upper quartile is 23.5, and the maximum is 34. On a box plot, it looks like this, where the minimum is at 12, median is at 9, so the lower quartile is 13.5, median, upper quartile, and the maximum. We draw a box plot around that, like that, and we have finished drawing our box plot. You can see this data set is not very evenly distributed. A lot of the data is squashed up in the first quarter. Okay, and then the last quarter is really spread out. That's a box plot. That's how you draw box plots. You may want to rewatch this video one more time so you can really see it in your own time. Thanks for watching today's video with Advanced Maths. If you enjoyed today's video, make sure to hit the like button below. Subscribe for future videos, and if you have any ideas for topics you're struggling with in maths and you'd like me to do a video on, please let me know in the comments. Thanks for watching and have a good day.